Let me welcome you to the 49th lecture of online NPTEL online certification course Drilling and Blasting Technology. Today our topic is special blasting techniques. So far the general blasting which is carried out in the surface and underground we have covered. So, from this lecture onward we will start different special blasting techniques. So, the first special blasting techniques which we are considering is ring hole blasting. So, ring hole blasting is a special blasting techniques, we will consider how to carry out it. So, before this, so far we have covered the drilling and blasting techniques, we have carried out the different tutorials, we understand how the rock and rock mass properties are influencing them. So, objective of this lecture is to understand the blasting in ring hole pattern, which is basically used in the underground mines for excavating a large mining block together. So, how this ring hole blastings are carried out, what are their applicability, what is the design and how to execute that one, we will discuss in this lecture. This complete lectures is basically prepared and all the material credit goes to Sri Ashish Vishwakarma, who is a research scholar and also employee with the CIMFR. He has done this fantastic work which we are using for this lecture. So, before starting this, let us first understand the condition of underground metal mines. Basically, what is happening in underground metal mines, we may have our deposits like this. So, it may be extended for 200-300 meter and there may be a massive one also. There may be some new deposit which is not discovered yet. So, there are different approach to do this one. As these deposits, these are, if you look at this in a 3-dimensional way, so this is the strike direction. So, this is the strike, this is the dip of the deposit, you can understand. So, this strike direction it may be kilometers, it may be few hundred meters, but depth wise it is also in few hundred meters. That is the problem and that is why the multi-level operations are being carried out in the underground mines. You can see this is one level, this is another level, this is another level, this is another level and there are difference maybe 30 to 60 meter differences are there between this RL differences are there between these levels. So, that is why unlike coal mine etc., where the bedded deposits are there, in those cases only the single level operation is carried out, but as the deposits are inclined like this, we operate it in a multiple level. So, this is basically the multiple level operation is being practiced in this particular underground mining case. There are some coal mines also where this highly inclined deposits are there. There also the multi-level operations are carried out. Now, in this multi-level operation where it is carried out, ring blasting is very commonly used in many cases. There are few particular conditions like sub-level stopping methods, sub-level caving methods. In those conditions, this ring blastings are very popularly carried out. In this case, the complete ore body, not ore body, for a particular slice of the ore body is basically excavated between the levels. So, if we look into this once again, suppose we are having and we have to excavate, this is one level, this is another level. So, if we wish to excavate this one slice of this one, we go for drilling of this one like this. And blast it, so that one slice, that is one slice of this one, that one particular slice of this one can be excavated. So, this type of drilling, as it is done in a ring pattern, this is called ring drilling, and this blasting is called ring hole blasting or blasting in a ring pattern. So, to understand this, we need to understand what is sublevel stoping. So, this is a sublevel stoping operations. This video is available in the YouTube. So, you can see the multiple levels are being developed first, and as the multiple level are being developed. So, these are the multiple levels developed, one here, and first the slot between these are made, which will act as the free face. Then the other holes are drilled. You can see the slot is made and the other holes are being drilled. You can see the other holes are being drilled and these holes are drilled in a ring pattern. So, as it is drilled in a ring pattern, then it is blasted. So, the excavation is made and the material is removed from the lower part, then again the drilling is carried out and it is blasted. So, the whole material has come out, then it is taken out. Similarly, again it is further. So, slice by slice it is being taken, slice by slice it is being taken. After removal of the lower part, then again we go for removal of the upper one. Okay. So, this is the upper one is being taken. So, the lower one is moving ahead of the upper one, so that the complete material can be taken. We can see another video here also. Here the complete, you can see the rock mass is showing. This is the surface. From the surface we can access the rock mass. This is a zigzag way, is called decline. In this zigzag way we can reach. There may be shaft, there may be incline. So, from here we developed the different levels, we enter into the different levels. So, from here we can make the slot from between the levels, then we go for the drilling. You can see the ring drillings are made and then one slice by one slice. See, this one slice is first charged, now it is blasted. Okay. Now, the blasted material is removed. Now, you can see the second is charged, removed, third is charged, removed. So, like that way it is slice by slice it is taken, and by this way the complete material can be removed. So, that is why ring blasting is a large scale blasting, which is practiced to take out the complete rock mass. Now, this is basically ring blasting is basically practiced in our sometimes in development work also, sometimes mainly in the production base. There are two types of blasting carried out, one is in a ring form, another is in a long hole blasting. So, long hole blasting in ring form in VCR vertical crater-rated, where the holes are drilled parallelly, not in a ring form, and these are the large diameter drill holes are made, because the different holes are because the long drill holes are made. As the long drill holes are made, that is why the diameter has to be increased, otherwise the hole will be deviate a lot. So, the concept of this one is that ring has to be made either from the sides or from the middle. So, it is depending on which way we are basically carrying out our development. If the development is, if this is the ore body and we are having the labels, here you can see the labels are at the corner, these labels are being shown, one label is here, another label is here. These are the labels, one drift is here, another drift is here. So, the ring is basically drilled from one drift and this is the draw point probably. So, from here the rings are made and this is blasted. So, this one slice is blasted. After this one slice is blasted, this material is allowed to drop here. So, their slot raises are made. Actually, this has to be explained to you first. This is the lower level, you can see. This lower level is also act as a draw level. The draw level means whatever material is blasted, that is taken out from this level. Here the machines are operating under a completely safe roof, and that is why you can see these are the solid rock mass. This solid rock mass is basically guiding the rock to come in this direction. So, first at the very beginning, our first we carry out this drilling. So, this portion is basically drilling and blasted first. So, after drilling and blasting this one, we have basically this is now void, this portion is now void, there is nothing, only these rock masses are left. So, whatever the material is dropped from here, now this is guiding this into this particular opening, horizontal opening that is made. So, this is acting as the draw level. So, from this draw level, this material is being removed, and after creating this one, this is in very safe condition. We go for main ring blasting at this particular position, and this wrong holes are drilled and this is blasted. This is allowing the one slice of material to drop down here. The moment it is dropped down, as it is guided like this, then the material whatever is dropping at this position, this will be sliding on this and there is a opening. So, this part is opening. So, the material is coming down here. So, the excavator will come here and take out that material. So, whatever will be blasted above this, this will be guided here. So, these are the rock masses, solid rock pillars, this is the opening, this is the rock pillar. So, this opening is basically allowed to come down the material onto this, and the excavator is coming from this direction under a safe roof condition, take out this one. So, this is basically carried out in this position. In this position, this is basically guiding all this fragmented rock into this, into this, into this. This is the three draw points are made. So, this is basically applicable for a very wide, where the thickness is very large, say 40 meter, 50 meter thickness is there of the ore body. There we make a number of draw levels, allowing the ring blasting to drop down all the material, and these are the in between levels, sub levels, and there may be another similar level in the top. Okay. So, that is the way basically it is carried out. So, this ring are basically allowing. So, first this one is excavated. So, what will happening, if it is observing from this side, then this is the draw level, these are the sub levels. So, what is happening here, this face is at this position, this face is at this position, and this face is at this position. So, the lower one is ahead of the upper one, so that this blasting is allowed. So, the moment we blast this one, this is allowing, now this portion will move to this, and this will allow the fragmented rock at this position. Now, from this area our excavator can take it out. Okay. From this level our excavator can take it out, and then if we go for blasting this one will again drop down. Let us have blue color. So, this portion material will drop down here. Okay. So, otherwise what will happen, it will drop down on this, we cannot excavate, that is why this is always ahead of this one, that upper one will be at the least ahead position. So, this is the way the excavation procedures are considered, and by this way we gradually extend our excavation. But the essential requirement in this is all the blasting is carried out. You can see it is a basically half ring condition. This is not a full ring, this is a half ring condition is basically followed at this position. There are cases where it may be possible that we need to have the full ring condition. So, if that is the case, generally we go for like this way, we are having our sub-level we are having our sub-level at this position, and this is our draw level, and we carry out our drilling like this. So, if this is the condition, in that case we are basically taking out, if you look into the plan view of this one, this is the draw level, this is the sub level, this is another sub level, this is another sub level. So, basically this complete portion, this is also being drilled, this is also being drilled, are blasted together, okay, and this is allowing the fragmenting rock deposited here. Similarly, this portion will be again drilled together, and this will allowing the blast. So, this face will move together, this face will move together. So, this is the way it is carried out, the blasting is carried out for this particular case. So, this is the ring blasting procedure in a nutshell. So, the first requirement in a ring blasting is to make the slot, because the slot will act as the free face for the rest of the hole. So, here you can see first this is the slot. So, ahead of the blast, first the slot has to be made, then the other holes will be blasted, so that the ring can be completed. Okay. So, first this slot is made in the central. If you see the video, the first video, if you look at that again, you can see the first the slot was made and then that was extended. So, this is the formation of the slot, and that is why the slot has to be designed very particularly. Often in case of slot, the small blasting is a combination of small blasting is carried out, then the ring blasting is carried out at a full phase. So, this is the plan view, this is the plan view of the slot position. So, this is the, if you look from this position, if you look at this, the slot looks like this. So, slot looks like this, the other holes are to be placed in this direction, and this is basically gradually, if our movement is this side, we basically move this one, this will act as the free face for the following blasting. So, this is the design blast design for the slots. Basically, it is similar to the burn cut blasting, but instead of burn cut we do it in the front side, horizontally the drilling is carried out, but here the burn cut is basically followed vertically downward direction. So, you can consider as the we are also having in this case a single free face. So, that is why a similar blasting practice has to be carried out. So, this is the blasting practice carried out, and you can see these are the empty holes, these are the empty holes, and these are the charged holes. So, this is also a typical 4 square type, this is also a typical 4 square type burn cut. Okay. So, that is practiced at this particular mines. A typical design for the burn cut is there may be other variations in the design. So, these are the different variations of the design. 3 meter by 2 meter slot is considered for this particular case. Now, a numerical simulation approach which is now possible with different softwares like Autodyne, these things are available, where we can carry out the simulation prior to the blasting, and this is one such simulation where the numerical simulation is made for this particular blasting operations, and this slot holes for the slot blasting reverse holes and main holes are being positioned, and that is the blasting results are observed in the simulation package. Okay. However, you must remember that simulation results vary largely with the actual conditions, but anyway that gives you a prior idea before the blasting you can understand, and based on that you can change the charge positioning, especially the charge positioning, spatial distribution of the charge can be carried out there. So, in fact, the positioning of the, that is the charging, how the charge has to be made, whether deck charging should be there or not, all these decisions, what should be the amount of stemming, that can be easily simulated in this numerical analysis software. Slot blasting can be carried out in phases also. So, gradually one by one phases it can be carried out, and from that it is a typical, in next lecture we will cover the VCR blasting technique. So, in that case it is gradually, basically the long holes are drilled, but blasted gradually. So, similar technique can be adopted here also, but once the slot is made, first when there is nothing available. So, when the slot is made first time, that time it may be possible, next time onward the complete long holes can be blasted together, because the old slot will act as the free face to the new slot. So, that is the benefit of the slot blasting. So, these are some of the terminology one must know about the ring blasting. Ring is the collection of blast holes, which is basically drilled in a radial manner from a particular center position. Okay. That is radially made, or from a particular central opening, that is radially made. The ring may be half ring, that means it may be only the vertical upward half or the lower half. It may be full ring if it is carried out for whole 360 degree, then it may be full ring. The toe spacings are different from the mouth spacing, because you understand from the mouth, this is the opening, from here the drilling is being carried out like this. So, the mouth spacing, that is the crest spacing, are different from the toe spacing. So, that is very important part, and one must be very careful on that, because as if you look into 3 dimension way, from here the holes are drilled like this. Okay. So, the spacings here are different, though burdens are same for each and every place, because the burden is same for all the positions. So, if this is the made here or here, so burden is same, but the spacings are different. So, that is very important aspect must be considered where the while the designing is considered. However, burden is same, but burden is not distributed throughout the face. Burden is concentrically distributed in the mouth part, burden is not there. So, that is why horizontally up to 180 degree it has to be considered. That means, from 0 to 180 this angle must be properly drilled to achieve the excavation in the full burden. So, this charge distribution must be very well, because as the toe spacings are high, huge charge concentration must be provided in the toe position, so that the proper fragmentation or cracking of the material may be achieved. That is, the decision on the angle of the ring holes are very important, so that the toe spacing should not be very high. And as the long hole drilling is made, the deviation is also very problematic, and that must be one must be careful about that. So, this is the formula. One formula is given by Rushton, another concept is also given by Ashby. So, this is more or less similar to each other, the maximum values and minimum values are more or less matching with each other, and that is why more or less 20 d to 40 d can be considered as the optimum burden for in this particular conditions. So, this is the different concept of ring blasting. It may be all are, you can see the half blastings are basically carried out, and this ring, these are the ring burden, these are the ring burden for each slot. So, once it is blasted, so this is burden, one of this one is being excavated and coming down to this. So, and the ring holes are placed. So, this is from the front view, you can see this is the rings are made. So, and this is one slice in this direction, one slice is made of that one. So, that is the excavation is coming out. Generally, single row blast is preferred, but multiple row can be blasted if the performance achieved are good. That is the blastability of the rock, if that is cooperating with the performance of the blast, then that can be easily followed. One important thing is that how to control the drilling, that means how to demarcate the ore body. This is very crucial decision has to be taken. This is governed by the drill cuttings. Once the drill cuttings is found, it is punctured into the hang wall, immediately the drilling has to be stopped. The more the overbreak into the blasting results into the dilution of the ore. So, basically that is why this long hole blastings, ring blastings are practiced, where the dilution, a little bit dilution in the ore can be accepted. In those cases only this is accepted, because this is very low cost excavation system, and little bit dilution can be considered as the economical in this also. So, that is one important aspects in that, the dilution, that is the overbreak is very high in case of ring drilling. That is why crucial positioning of the hole and spatial distribution inside the hole is very important in ring blasting. So, these figures we have already discussed. You can see a number of videos available in the YouTube. So, those video animated, specially animated videos, those videos will clear the concept. This is one case study where you can see the ore body is also having some bent in these. So, in those cases you have to carry out drilling through hang wall, but the charging is confined only in the ore part, which basically allow the not restrict the dilution. This portion will not be blasted, no blasting on this. So, this will not be coming into the ore. So, dilution can be arrested there, and otherwise the rest portion is drilled and blasted. So, this is particularly condition which is practiced in Kayad mines. This case study is carried out by CIMFR team, and they have executed it very well. These are another concept in the Kayad mine which is used, where the deck charging is practiced. That is basically the distribution of the charge considering the rock mass condition is considered, and this is already we have discussed. Whenever the deck charging has to be carried out, there must be more than 12D separation has to be followed, so that the sympathetic detonation can be avoided. So, that has to be considered. This is the multiple decks are used for having better distribution of the explosives. This is the delay sequence, case to case, how the delay sequence, that is the hole close to the slots has to be blasted first, then gradually the delays are given to the periphery holes. This is some of the charging figures. This is a very important one. One can see how deep it is. This is from the upper level to the lower portion. One can see the burdens also, how the burdens are looking into this. So, this is very important, and these are the references. So, this is more or less all about the ring hole blasting. We will discuss the blasting for VCR method of operation in the next class. Thank you.